Hey guys, my name is Alyssa Drakes, and as an art major, I spend a lot of my time in the art studio. And since being in my physical science class, I couldn't help but start to notice all of the simple machines that I use here. Recently, for my 3D composition class, I made this sculpture by carving, shaving, and cutting pieces away. For this project, the tools that I used the most were this X-Acto knife and this chisel. And these two tools are classified as wedges. And wedges are used to assist in the separating, splitting, or holding of objects in place. If you look at the shape of these wedges, they are basically two inclined planes that are pushed together, creating a triangular form with a sharp tip. So, take this chisel for example. It has a very sharp edge and it can be used to split the plaster in half. But to use this simple machine more effectively, you can add some more outside force with an hammer. So basically, you'll take your sharp side and you'll insert it into your plaster and you'll apply the force of the hammer on top of it. By inserting the sharp end into the surface of the plaster and using the hammer to increase the force against it, it allows you to cut it. Now, another fun fact about myself is that I absolutely love to read, so I thought, what better way to show how the force of a chisel works than to incorporate books and kind of show that example. Due to the triangular shape of the wedge, it is able to change the direction of the import force. The momentum is transferred perpendicularly to the slope of the wedge, causing the objects to split apart. Now, every simple machine has a mechanical advantage, which is basically the number of times this tool will apply or multiply the force you put in. A wedge's mechanical advantage is calculated by its width and its length. And depending on the length of the wedge, or also known as the sharpness, you will have to apply either more or less force. To calculate for its ideal mechanical advantage, you will take its length and divide it by its thickness. With the chisel that I use, its length, which is represented by the purple line, was 1 centimeter, and its thickness, represented by the blue line, is 0.5 centimeters. When you divide this, its mechanical advantage is 2, so this wedge is doubling the amount of force you apply to it. If I could be totally honest here, as a future art teacher, I would have never imagined myself solving math problems and equations while I worked. But since art is a very hands-on class, I would explain wedges to my students by letting them experiment with cutting clay into pieces with different cutting tools. So right here I have my clay that I would be using, and essentially you'll take it and you'll just flatten it out all around. And then from there, I would preferably have safer knives than an X-Acto knife, but they could just cut and notice how it splits the clay in half. You can use this to just show a more bigger visualization of how knives work. And since this is thicker, it makes the equator between the two clay forms. You can see the difference between the line that I've cut with the X-Acto knife and the line that I cut with the fake wedge. And you can see how much they truly separate apart. This clay example and the example with the books will help my students to visualize the properties that wedges have and appreciate the assistance that these tools and other clay tools and other art materials provide us with in the art studio.